In this episode, we take 3 privacy controls that show up again and again in responsible AI work and learn how to audit them in a practical, beginner-friendly way: consent, minimization, and purpose limits. These ideas can sound like legal terms or policy slogans, but they become very concrete when you picture an AI system as a pipeline that pulls information from people, transforms it, and then produces outputs that can influence decisions. Consent is about whether people meaningfully agreed to the collection and use of their information in the way the organization is actually using it. Minimization is about limiting data to what is necessary, so the system is not fed extra personal detail just because it is convenient. Purpose limits are about preventing quiet reuse, where data gathered for one reason gets repurposed for another without a fair warning or a legitimate justification. Auditing these controls is not about catching people doing something evil. It is about checking whether the guardrails work under real-world pressure. By the end, you should be able to listen to an AI use case and mentally run these 3 controls like a checklist in your head, even without technical tools. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start with consent, because it is the most commonly misunderstood control in privacy conversations. Beginners often think consent is a box someone checks once, and then the organization can do anything forever. Real consent, when it is used as a basis for processing, should be informed, specific, freely given, and connected to the actual use. That means the person needs to understand what data is collected, what it will be used for, who it may be shared with, and what the consequences are, all in language a normal person can follow. In an AI context, consent questions often include whether interactions may be used to train models, whether prompts and outputs are logged, and whether data will be combined across sources. Auditing consent means you are not only reading a policy, but testing whether the experience a person has matches what the organization claims. If the system's behavior would surprise a reasonable person, consent is likely weak even if a legal team can point to a statement somewhere. A practical way to audit consent is to trace the user journey from the moment data is collected to the moment it is used in training or decision-making. Ask where the consent opportunity appears, such as during account creation, during a transaction, or at the moment a feature is used. Then ask what the person actually sees at that moment, and whether it clearly explains the AI use, not just general data use. A common failure is that notice is general, while the AI use is specific and impactful, like automated profiling or ranking. Another failure is bundling, where consent for one thing is tied to access for something unrelated, making it feel coerced rather than freely given. Also watch for consent that is vague about future use, like saying data may be used to improve services without explaining that it may train models that later influence decisions. The audit mindset is to treat consent as a living promise and verify whether the organization is keeping that promise. Consent also includes the ability to change one's mind, because privacy is not a one-way door. In many contexts, meaningful consent implies there is a practical way to withdraw consent and a clear explanation of what happens when someone does. Auditing this does not require complex knowledge. It requires asking what the organization does when a user opts out of training use or requests deletion. If the organization says opt-out exists, check whether it is easy to find and whether it actually changes behavior in a reasonable time. If the organization says withdrawal is honored, check whether there is a process to stop future use of data and to address stored logs or datasets that include that person. Even when the organization cannot fully remove influence from an already trained model, it should be honest about the limits and should prevent new inclusion going forward. A consent control that cannot be exercised in practice is closer to a marketing claim than a privacy safeguard. Now move to minimization, which is the control that can reduce privacy risk the fastest because it shrinks the amount of personal information at risk. Minimization is not about starving the system of useful information. It is about matching the dataset to the purpose and resisting the urge to collect everything because storage is cheap. In AI, minimization matters because training data can be reused, copied, labeled by humans, shared with vendors, and retained for long periods, multiplying exposure. Auditing minimization begins with a simple question: which data elements are truly required to achieve the stated outcome? Then you ask whether each element is present because it is necessary or because it was available. You also consider whether the same outcome could be achieved with less sensitive alternatives, like using aggregate behavior patterns instead of detailed personal histories. This is a control you can audit with reasoning, documentation review, and sampling, not with advanced algorithms. A practical minimization audit checks for three kinds of unnecessary data that often sneak into AI pipelines. The first is free text, because free text is where humans accidentally include personal details like health information, family circumstances, or confidential notes. The second is unique identifiers, because identifiers make linkage easier, and many AI tasks do not require them once the data is joined and cleaned. The third is sensitive categories, like biometrics, children's data, financial details, and other high-risk information, which should only be used when the purpose clearly demands it and when controls are strong. Minimization also includes retention limits, because data that is no longer needed should not be kept just in case. When you audit, look for evidence that datasets have defined retention periods, that old data is removed, and that training pipelines do not quietly keep copies forever. If there is no clear end-of-life plan for training data, minimization is incomplete. Minimization can also be audited by checking how the organization handles prompts and outputs, because these can become a new dataset of personal information even if the original training data was minimized. If users can type anything into a model, they will sometimes paste personal records, private emails, or sensitive internal notes, especially if they think the model will help. If the organization stores prompts and outputs for troubleshooting or improvement, it may be collecting a stream of personal data it never planned to collect. A minimization audit asks whether prompt logging is limited, whether sensitive content is filtered or redacted, whether retention is short, and whether access is restricted to those who truly need it. It also asks whether the organization trains users not to input sensitive content, because user behavior can defeat a program's best intentions. Minimization is as much about guiding and constraining human use as it is about cleaning datasets. Purpose limits are the third control, and they address one of the most common ways privacy trust is broken. Data collected for one reason gets used for a different reason that feels unfair or unexpected. Purpose limits are especially important in AI because models benefit from large datasets, and large datasets often come from prior interactions where people were not thinking about model training. Auditing purpose limits means verifying that the organization has defined purposes for data use and that those purposes restrict reuse. A classic failure is function creep, where a model begins as a support tool and gradually becomes a scoring tool used to rank people, monitor behavior, or decide eligibility. Another failure is cross-context reuse, like using employee wellness data to predict performance risk, or using student learning data to infer personal traits unrelated to education. Purpose limits exist to prevent these shifts from happening quietly. A practical way to audit purpose limits is to choose a dataset used by an AI system and ask for its original collection purpose. Then compare that purpose to the current AI use. If the purposes match closely, you still check whether the use has expanded in ways that change expectations, such as moving from internal analytics to automated decisions. If the purposes do not match, you ask what approval process allowed the new use, what notice was given, and what safeguards were added. You also check whether the organization uses purpose statements that are so broad they mean nothing, because vague purposes like improving services can be stretched to justify almost anything. A good purpose limit is specific enough that a reasonable person can understand it and specific enough that auditors can tell when it is being violated. When purpose limits are real, they cause projects to stop, pivot, or redesign when reuse does not fit. Purpose limits also show up in vendor relationships, because sharing data with vendors can create new purposes outside the organization's control. If an organization sends data to a vendor-hosted model service, the vendor may have its own rules about using that data to improve its services unless the contract prohibits it. Auditing purpose limits means checking whether contracts and settings restrict vendor reuse, retention, and training. It also means checking whether the organization understands where data goes, how long it is kept, and whether the vendor can access it. Beginners can audit this by focusing on basic questions. Is the vendor allowed to use the data beyond providing the service? Can the vendor use it to train future models? And can the organization require deletion? If the answers are unclear, purpose limits are not enforced at the boundary where risk often increases. A strong program treats the vendor boundary as a place to tighten controls, not loosen them. Now put consent, minimization, and purpose limits together, because in real audits they reinforce each other. Consent can fail if the data is used for a new purpose the person did not anticipate, which is why purpose limits matter. Minimization can reduce the blast radius when consent is unclear or when purpose drift happens, because less personal data means less potential harm. Purpose limits can reduce pressure on minimization by preventing teams from constantly searching for more data to feed new use cases. Auditing these controls together helps you see whether the organization is relying too heavily on one control. For example, an organization might lean on consent language to justify broad collection instead of minimizing data, or it might claim minimization while quietly reusing data across new purposes. A balanced privacy program uses all three controls so that if one is imperfect, the others still reduce risk. A practical audit also checks whether these controls survive business pressure, because pressure is when privacy programs tend to break. If a product team wants a model to perform better, the quickest move is often to add more data, keep it longer, and reuse it across features. If leadership wants faster growth, consent flows may be simplified or hidden to reduce friction. If a new market opportunity appears, purpose drift can happen quickly as teams repurpose existing datasets. The audit question is whether the organization has decision points that force reflection, documentation, and approvals when these pressures appear. You are looking for evidence that teams have been told no, that datasets were reduced, or that a use case was redesigned to fit purpose limits. If every privacy control becomes flexible whenever speed is demanded, the program is not a control, it is a suggestion. To close, auditing privacy controls for AI using consent, minimization, and purpose limits is about verifying promises and verifying boundaries. Consent is a promise to people about how their information will be used, and auditing it means checking whether that promise is clear, specific, and usable in practice, including withdrawal. Minimization is a boundary that reduces exposure by limiting what is collected, what is stored, and what is logged, and auditing it means looking for real reductions, not slogans. Purpose limits are boundaries that prevent surprise reuse and function creep, and auditing them means comparing original collection reasons to current AI uses and checking whether changes were approved and communicated. When you can audit these controls in plain language, you can spot weak privacy programs even when they look polished. That skill is valuable because it helps prevent the kind of quiet privacy failures that erode trust, trigger legal problems, and harm real people long before anyone notices.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.